Hey guys, welcome back to my channel. In today's video, we are going to discuss what prime number is, and then we are going to check whether a number is prime or not, right? So let's see how to check. So before going into this portion to check whether a number is prime or not, let's see what prime number is. So a prime number is a number that has two factors. One and the number itself. For example, let's say 3. How many factors are there for 3? 1 is a factor of 3. Can 2 be a factor of 3? No, because 2 cannot divide 3 completely, right? Can 3 be a factor of 3? Yes. So 1 and 3, these two are the factors of 3. So what prime number says, that prime number is having only two factors, 1 and the number itself. Hence 3 is a prime number. So let's take some other example. Let's take 4. 1 is a factor of 4. 2 is a factor of 4. Why? Because 2 can divide 4 completely. 3 is a factor of 4. No. And then 4 is a factor of 4. Yes. So there are 3 factors. 1, 2 and 4. But according to prime number, it should have only 2 factors. They are 1 and the number itself, but we have one extra factor, that is 2. That means this number cannot be a prime number, right? Let's take one more example. Let's take 5. 1 is a factor of 5, 2 cannot be, 3 cannot be, 4 cannot be, 5, yeah, 5 is a factor of 5. So now 5 has two factors, 1 and the number itself. So 5 is a prime number, right? So a prime number is a number that has two factors, 1 and the number itself, right? Now let's see how to solve this. See, we can just run a loop from 1 till n, and we can just check if there is any factor except 1 and n, right? So let's say I'm running a for loop from I is equal to 1 till n, and I'm checking whether n is divisible by I or not. If yes, I'm going to keep something like a count variable. I'm going to increase this count plus plus, and after this for loop I will just check whether the count equals to 2 or not, because 1 and n, they will anyway be the factors, so there will be two factors for sure. So if count is 2, that means they are the only factors, right? So if there is some other factor, we will say that the number is not prime, right? So here we will be printing something like prime number, else we will be printing not prime. So that's how you will be solving this problem. So the time complexity will be of n. Why? Because you are iterating from I equals to 1 till n. So the space complexity will be of 1, since we are not using any extra space here. So this is a brute force solution. Can we optimize it? Can we optimize it further? If you have seen my last videos, we don't have to check from 1 till n to find the divisor. We don't have to check. We can just go from 1 till square root of n. Why? I have given a detailed explanation about this in my last video. So if you haven't watched it, please go and watch it. After that only come back to this video. But still, I will just give you a short explanation. So let's say a number is given, let's say 16, right? So 16's factors are 1, 2, 4, 8, 16, right? So if 1 is a factor of 16, 1 into something will be giving 16. If 2 is a factor of 16, 2 into something will give 16. Similarly, 4 into something will give 16. So 8 into something will give 16, and 16 into something will give 16. And what are these somethings? They are also factors. They are also factors. Because if 1 can divide 16 completely, this digit can also divide 16 completely, right? So 1 into 16, 2 into 8, 4 into 4, 8 into 4, then 16 into 1, right? So can you see a pattern here? If I draw a line here, can you see that these numbers, these factors, we can get from here itself? And what is this number? What is 4? 4 is the square root of 16. So basically, we just have to loop till 4, right? So we just have to loop till square root of n, and then we will be checking if there is a divisor or not, or if there is a factor or not, right? So that's how you are going to solve this in of square root of n time complexity. So we just reduce the time complexity from of n to of square root of n. So let's code the solution. Int n, take the input. We are going to maintain a count variable for int I equals to 1. I starts from 1 and I will go till n. Okay. This is the brute force solution. After this, we will go for the optimized one, that is square root of n. Till square root of n, we will be going. So now let's execute this one. If I can divide n completely, we will just increment it. That means we have got a factor here, right? We will just check whether the count is equals to 2 or not. If it is, then just print that okay, it's a prime. Sorry, it's a prime. Else it's not a prime. Done. So let's run this. Let's give some input. Okay, I didn't give an input. Okay, let's give some input. Let's say 2. Yes, it's a prime number. Okay, let's give 5. Yeah, it's a prime number. Okay, let's give 4. Not a prime, right? So yeah, this is working fine. So the time complexity is actually of n, right? So we have to reduce it to square root of n, right? So what I'm going to do, I'm going to just replace this. I'm going to just replace this, and we will go till square root of n. And then we will check for I. And what I'm going to do, I'm not going to consider this one, right? Let's count from 2, because 1 will anyway, it will generate anyway a count, right? So let's start from 2 and we will be checking whether there was any factor or not. If there is some factor, that means it's not a prime. So I should change this. If it is 0, if there is no factors other than the first one, right? When I is equals to 1, that means 1 and the number itself will be the factors, right? So that we know, but we are trying to find, is there any other factor other than this? So that's the reason we are starting it from 2. And if there is any factor, the count will get increased. Otherwise, I can do one thing. I can just replace this like bool, let's say, is prime. First of all, it is true, but when it encounters some factor, is prime will become false, right? So we will just check here. is prime is true or not. If it is true, print it's prime. If it is not, it's not a prime. So let's run this. Okay, I didn't give an input. Let's run this for some input. Let's say I'm giving 2. Okay, 2 is a prime. Fine. Let's give 5. Okay, 5 is a prime. Let's give something like 6. Okay, 6 is not a prime. So that's how you solve this problem using of square root of n time complexity, right? So that's it for the video. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.